Hi, my name is Arnau, and today we're gonna start coding a kernel in Zig. We will be targeting x86-64 for now, but we may eventually port it to other architectures like RISC-V or ARch64, so we'll keep a more or less modular design that we can later expand on. But today, we'll only do a hello world. We'll be using Lemonade as a bootloader. All the code is available on GitHub. Let's start. First, we'll be writing the build.zig file. We'll create a kernel configuration struct that we will eventually expand, but will be as simple as a target architecture for now. For some architectures, we'll need to enable or disable certain features. This is the case of x86-64. We quickly create a function that takes an architecture as a parameter and returns what features should be enabled and disabled. For x86-64, we need to disable MMX, SSE, and AVX, while enabling software floats. Now, we can create our cross-compilation target. We'll leave the default optimizations. Now, create a compilation step for the kernel. The main file will be kernel/src/main.zig. We should also set the code mode to kernel, and PIE flag, position independent executable, to true. We need our own linker script too. We now create the top-level step that will run to compile the kernel. Compiling the kernel is not really enough, as you cannot do much with a kernel. We probably want to create an ISO image containing both the kernel and the bootloader, Lemonade. We may also want to run it in QEMU, so we'll create a script for that too. The first script, which we'll call lemonade.sh, will be very simple. It will git clone the Lemonade bootloader and call the make command on it. We also make sure to delete any prior cloning. Now, to build the ISO file, we write iso.sh. We'll be working on a folder called iso_root placed under Zig cache. So we make sure to create it and delete it if it already existed. Now, we'll copy the kernel and some Lemonade files. After that, we create EFI/boot and copy some more Lemonade files in there. We then create the ISO using Xorizo and install Lemonade on it. For the run_iso.sh, we just have to call QEMU with the appropriate flags. We can also print a new line for visual reasons. We can go back to build.zig now and create steps for running the scripts we just created. Make sure to add the dependencies between them. Now that we're at it, we can also create a new step for cleaning the working directory. And that's everything we need for the build system. We now have to write the linker script, which we'll call linker.ld, specify _start as the entry point, and define the program headers. For the sections, just make sure that they start at the appropriate address. Now, this is a fun part. Create a lemonade.cfg file, set the timeout and create a basic entry. This will be the Lemonade configuration file that specifies what the bootloader entry will look like and how to load the kernel. We're ready to write the kernel itself. We create the main.zig file. The _start function will be called by Lemonade, as that's what we specified in the linker script. However, as the stack doesn't contain a valid return address, we should declare it no return and put an endless loop in it. Let's go ahead and run it. We run the command zig build run iso, but nothing happens. We can see the Lemonade boot screen, but then it's all in black. There's really nothing wrong with it. In fact, it's working perfectly. We still haven't done anything. For now, just as a hello world, we'll write to port hex E9, where some emulators have the debug output on. We write some wrappers for the InB and OutB assembly instructions, and call them to print hi. Let's run it again. We can see hi printed to the console. We didn't print it on the screen, as that requires more work, but it sure is printing on the debug con, as QEMU calls it, and we can indeed see it in stdout. With that, we've done the bare bones of a 64-bit kernel. Don't forget the code is on GitHub. Also, if you've made it this far, you may want to subscribe so that you don't miss part 2. Thanks for watching.